Solving cubic equations, example 3. In this question, we asked to solve x cubed plus 5x squared plus 4x plus 20 equals to 0, given that one of the solutions is x equals to 2i. So here we're given one of the solutions and it's a complex solution. So knowing that x equals to 2i, and because it's a complex number, I can immediately say that x equals to negative 2i is also a solution, because you remember from the previous examples that complex solutions occur in pairs and we call them complex conjugates. So let's deal with these two solutions. So now when we multiply these two solutions, we're going to get one of the factors of the cubic expression, x cubed plus 5x squared plus 4x plus 20 equals to 0. So if x equals to 2i, I can say that x minus 2i will equal to 0, or x plus 2i will equal to 0 if I take my imaginary number across the equals to sign. So if I multiply these two numbers together, they are going to be the factors of my cubic equation, and they're going to be two of the factors of my cubic equation. And since each one equals to 0, and if I multiply them, I can deduce that the product will equal to 0. So I need to multiply this out, but I'm not going to do it the long way by applying the distributive property. I'm going to use the following method. So what I say is that I will get a quadratic expression, because when I multiply x times x, I'm going to get x squared. Then to find my middle term is going to be minus the sum of the roots. That would be the coefficient of x, and I need to find my constant in my quadratic expression, and that would be the product of the roots. And what I'm doing is I'm writing my expression in the form of ax squared plus bx plus c, as I will have a quadratic expression. So I need to find the sum of the roots and the product of the roots. So I've divided my page, and now I'm going to work out the sum of the roots. So to find the sum of the roots, it's going to be two I, so the first root is 2i, added to the second root is negative 2i, and this gives me 0. If I find the product, it's going to be 2i multiplied by negative 2i. This gives me minus 4i squared, and I know that I squared is negative 1, so negative 4 multiplied by negative 1 gives me positive 4. So I substitute these values. So substituting these values, I get x squared minus 0x plus 4. And this will be one of the factors. So let's just write down our cubic expression again. Right, so we see that x cubed plus 5x squared plus 4x plus 20 is going to be x squared plus 4. And to find the last factor, I'm going to do it again by the inspection method. So remember, with the inspection method, we're going to focus on the coefficient of x cubed and on the constant. Right, so I have 1x cubed, so x squared must be multiplied by x, 1x, to give me 1x cubed. The next thing I'm going to look at is going to be my constant. My constant has a value of 20, so I ask myself, 4 times what gives me 20? 4 times 5. So my second factor will be linear if my first factor is quadratic, and if my first factor had been quadratic, then my second factor sorry, if my first factor was linear, then my second factor would have been quadratic. Right, so now I'm ready to solve for x. So what we're going to do is we're going to go 0 equals to x squared plus 4 times x plus 5. Once again, we equate each factor to 0, so we're going to say x squared plus 4 equals to 0, or x plus 5 equals to 0. I'm going to take 4 across the equals to sign, so I get x squared equals to negative 4. So I know that x is going to be plus or minus the square root of negative 4, which gives me 2i, and those are the two solutions that I had initially. And then my third solution is going to be x equals to negative 5. So I have two imaginary solutions, or rather two complex solutions, and one real solution.